Section 4.3, derivatives and graphing. So of course derivatives have a lot of applications and things like that, such as the first derivative could tell you how fast something is changing. Well, it can also tell you about the shape of a graph. So if you look at this graph right here, then, whoops, sorry about that. Right here, the derivative is equal to 0. And at this bottom point, the derivative is equal to 0. When the function's going up, that means positive slope. And that means that the derivative is positive. And when it's going down, that would mean negative slope. So the derivative would be negative. Now, what about the second derivative? So, take a copy of the graph that I just made. There we go. Copy and paste. And if you look right about here, this is where the second derivative will equal 0. And then this shape is called concave down. And this shape is called concave up. Well, for this whole time, when it's concave up, that means that the second derivative is positive. And this time, when it's concave down, that means that the second derivative is negative. So down, negative, up, positive. Just like my attitude, up, positive. Okay then, let's look at some examples. So for example number 1, suppose that the function is 2x cubed plus 3x squared minus 12x plus 2. So I'm going to do all the work with the first derivative first and then move on to the second derivative. So for the first derivative, that's going to be 6x squared plus 6x minus 12. And then set it equal to 0 and find the critical values. And what I would like to do is factor out a 6. So that would leave x squared plus x minus 2. And perhaps this could be factored. If not, I could always use the quadratic formula. But I think this one could be factored. So it's going to be x, and then I need a 2 and a 1 in order to get a 2 right here. And one of them has to be negative and one of them has to be positive. And then if you check the middle term, this would be positive 2x minus an x is positive 1x. So this one actually factored. So this is going to give us an answer that x equals 1. And this is going to give us an answer that x equals negative 2. And then before going on, I want to graph it and make sure I got that part right. Because if I made a mistake right now, that mistake is just going to follow me through the rest of the problem. So, graph it, go to y equals, there it is, I already typed it in. And then when you go to zoom standard, it looks like this. And so up there, I can't quite see the top. So I'm going to go trace and then look at the y values. It's up to 15, 18, 20, 21, and then it's coming back down. So have the y value, let's say go up to 25, and then I should be able to see it. Okay, so the graph basically looks like this. And right here should be negative 2, and right here should be positive 1. So that should be the maximum point, and that should be the minimum point. And then trace and substitute a -2. So that is correct. So that's up there at a height of 22. And when I put in a 1, it's down here at -5, and that point is correct. All right, so far I've done everything correct. And then where is it increasing and where is it decreasing? So this is the part that's increasing, and also this part is increasing. So when you talk about where it's increasing, we're really talking about on the x-axis, for what values of x is it increasing? So that would be from -infinity up until -2. So for increasing, that would be from -infinity to -2, and then this would have a round parenthesis because at -2 itself, the derivative is not positive. The derivative actually equals 0 right there. And then also from 1 to the right, so union from 1 to infinity. And then the decreasing, so that is this middle part. Right here is when it's going down, 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 like the stock market. So that is between -2 and 1. And again, those have round parentheses because those actual numbers are not included, but it's everything in between. Next up, what about the second derivative? So this is example number 1, continued. So we've got the first derivative equals 6x squared plus 6x minus 12. Then what about the second derivative? So the second derivative is going to be 12x plus 6. Then set that equal to 0 and solve for x. So you could subtract 6 from both sides and then divide by 12 and then reduce the fraction, so that's -1/2. So I'll just make another copy of the picture. So the graph looked like this. And since I'm talking about the second derivative, I don't need these other numbers on there. And then at x equals -1/2, -1/2 is over here. So I need to redraw that picture. And I should have done it from this. Hey, calculator, wake up. Trace and put -1/2. So that's right there. So this point right here should have been moved over there. So it's more like this. And then right here is where x equals -1/2. And that point where it's changing from this is concave down to concave up, this is called an inflection point. So it inflects. And I guess I could even write that down. So that is at -0.5, 8.5. And then where is it concave up and concave down? And again, when you write this part down, we're talking about on the x-axis. So this part is concave down, so that is from -infinity up to the -1/2. And then this part is the concave up. And sometimes they just abbreviate it. This is concave down, and this is concave up. So for concave up, that would be from -1/2 to the right. So from -1/2 to infinity. Okay, so that's the basics. And now you're probably thinking, when do we get to do some trig? Well, how about right now? So for example number 2, the function is x plus 3 sine of 2x on the interval from 0 to 2 pi. So sometimes I graph first and then do the derivatives. Sometimes I do the derivative first. This time I'm going to graph first. So this one is x plus 3 sine of 2x. Change the window to go from 0 to 2 pi. And then this is at least 3. If you put a 2 pi in for x, that's 6. So probably going to go up to 10, I would say. I'm going to go from -10 to 10. Also, make sure that it's in radians. And there it goes. So when I take the derivative and set it equal to 0, there's going to be 1, 2, 3, 4 answers. And for this question, we're just going to do where is f of x increasing So first of all, we need the derivative. So the derivative is going to be 1 plus, then the derivative of sine is cosine. So it'll be cosine of 2x. And then don't forget the chain rule, so it's times 2. And then set the derivative equal to 0. Now recall the critical values could also happen if the derivative is undefined, but cosine is never undefined, so that doesn't happen here. Derivative equals 0, yes, that can happen. And then I'll just put the 2 and the 3 together, that's going to be 6. And then subtract 1. Next, divide by 6. And then, here's where those trigonometry skills come out. So this is saying, take a look at the cosine graph. So here's the cosine graph. And then when is it equal to -1/6? So if I put a little horizontal line right here at the y value -1/6, then there's going to be 2 answers. One answer can be found by taking cosine inverse. So what is cosine inverse of a -1/6? 1.738. So that means this x value is 1.738. Now, believe it or not, this graph is symmetric. So if the length from here to here is 1.738, then the length from 2 pi to this answer is also 1.738. So that means this one is going to be, if you start at 2 pi and then go to the left by 1.738, that's going to be the second answer. Now, those aren't the final answers because this said 2x in the parentheses. So we would actually have 2x equals 1.738. 2x equals 2 pi minus 1.738. And if you remember the graph, the derivative will equal 0, 1, 2, 3, 4 times. So that means that we need 2 more answers. So if you follow this cosine graph out for another cycle and you continue the red line, there's going to be 2 more answers. Well, because the period of cosine is 2 pi, that means when I added on this second cycle, I added on another 2 pi. So just take this answer and add on another 2 pi. So going from here to there is going to be 1.738 plus 2 pi. So a third answer is going to be, I'll write it right here, 2x equals 1.738 plus 2 pi. And then also, if you take this answer and add on 2 pi, you'll get this fourth one over here. So if I add a 2 pi onto this, that's actually going to be 4 pi minus 1.738. Now, in order to get the 4 answers, we need to divide them all by 2. So there's 1.738 gets divided by 2. So x equals 0.869. And then for this one, 2 pi minus 1.738, all of that, put it in the parentheses and divide by 2. So that's going to be 2.273. Now on to this one, put it in parentheses, 1.738 plus 2 pi. That's not pi. Come here, pi. Divided by 2. So x equals 4.011. And then for this one, 4 pi minus 1.738. And then all of that gets divided by 2. So then it's 5.414. And before I start celebrating, I want to check and make sure that's right. So this, when it's at the top of that hill, that one right there should be the 0.869. Perfecto. Y el próximo es perfecto. And correct. 5.414. Easy money. But wait, we're not done, because I was asking, where is it increasing? So that means that from 0 until that first one, that's increasing. So now I could look at the actual graph, which looks like this. Oh, sorry, that's not on the screen. There we go. And so that means that this part is increasing, this part is increasing, and this part is increasing. And then right here was the 0.869. And then starting right here, this is the x equals 2.273. And then at this point, that's 4.011. And then this point is 5.414. So for increasing, and sometimes I don't feel like spelling the word increasing, so I just abbreviate it. So that would go from 0 until this one, so from 0 to 0.869. And this interval should actually look like this. Because at 0, it's actually increasing. Because I did not get 0 as one of the answers here, that means it's actually increasing right there. And if you widen the screen a little bit to include what happens at 0, then you'll see as it was going through 0, it actually was increasing. Okay, then the next one that's increasing, so that's from this one to this one. 2.273 to 4.011. And then the last interval would go from 5.414. And then the very end of the interval is 2 pi. And that should be 2 pi with a square bracket. So that is where it's increasing. Okay. Now there's something called the second derivative test. Which, believe it or not, uses the second derivative. So basically it goes like this. If the second derivative is negative, that means you know it's concave down. And let's suppose that you found out that right there, the derivative equals 0. So if it's concave down, and the derivative equals 0, then that means there's a maximum. Now, if it's concave up, so like this, and you found out that the derivative equals 0 right here, or it could be that the derivative does not exist, it might be a cusp, well, then that is at a minimum point. Now, you don't always have to use this theorem, but there are going to be times when you look at the graph of the function and it looks like this. And you found out that the derivative equals 0 right here. So if it looks like this and it's obvious that that's at the top of the hill or this is at the bottom of the valley, then you could pretty much see where the minimum maximums are. But there would be times when it just looks like that, and just looking at it, I cannot tell if that's a minimum or a maximum. So then I would use the second derivative test to find out, is this concave up or concave down? Even though it looks like a straight line, it's actually either concave up or concave down. So let's do that. So for example, number 3, use the second derivative test to find minimums and maximums. And this function is going to be x over x squared plus 1. Well, the first thing we need to do is take the derivative, the first derivative, which means that we get to use the quotient rule. So for the quotient rule, I know that the bottom has to be squared, so I'm going to go ahead and do that now. And then start taking the derivative on the top would be 1, and then leave x squared plus 1 alone. Then it goes minus, leave x alone, and take the derivative of x squared plus 1. And so this is going to be negative 2x squared and a positive 1, so that means it's negative x squared. And then plus that 1. And then when you get a rational function, you could then treat it separately. When you take the derivative, you could set the top equal to 0 and set the bottom equal to 0. So one of them is going to be when the derivative equals 0, and the other one is going to be when the derivative does not exist. N'existe pas. So this one is when the top equals 0. And then we could do the algebra, Add x squared to both sides, take the square root, and when you do, don't forget to put plus or minus the square root of 1. So there's two answers. When you set the bottom equal to 0, that's where it does not exist. So take the square root of both sides, subtract 1 from both sides, take the square root, and then it's the square root of a negative number, and we do not use imaginary numbers in calculus, or at least in Math 3A, 3B, 3C. So at this point, there's no solution for that, but there is for positive 1 and negative 1. Well, since we're supposed to be using the second derivative, I vote for taking the second derivative. So let's see. This is number 3, continued. And we have that the first derivative equals negative x squared plus 1 over x squared plus 1 is squared. Okay, then I can use this paper to do the second derivative. So then the second derivative is going to be, so as part of the rule, this needs to be squared. So when you square a square, it makes it to the fourth. And now start taking derivatives by taking the derivative of the top. So that will be negative 2x gets multiplied with x squared plus 1 squared minus, now leave negative x squared plus 1 alone, and now take the derivative of this, which means you bring the power 2 down, leave the inside alone for now. Now it's to an exponent of 1, and now do the chain rule. The derivative of the inside is a 2x. And then if you look at the top, this has an x squared plus 1, and this has an x squared plus 1. Also, this has a 2x, and this has a 2x. So I'm going to go ahead and factor out 2x, and also x squared plus 1. And then what remains? So this got factored out, but the negative did not, so the negative is still going to be there. One of these got factored out, but one remains, so it's going to be negative x squared plus 1. This got factored out, and this got factored out, so this did not, and this did not. So then it's going to say minus, and I'll just move the 2 in front. And then in the parentheses, negative x squared plus 1. I love algebra. And then I could do a little bit of canceling because x squared plus 1 will cancel one of these. So now it leaves it to the third. And then this 2x is still on the outside. And then this is going to be negative x squared. And these two will actually make a positive 2x squared. So that's 2x squared minus 1 is x squared. And then, let's see, this and this would make a negative 2. And this would make negative 1, so that makes negative 3. Okay, now we just need to know, is the second derivative positive or is the second derivative negative? So if you remember, we got x equals positive 1 and x equals negative 1. So I need to test those two. So if x equals positive 1, it's going to be the second derivative at positive 1 equals, so this would just be 2 times 1. This would be 1 minus 3. And then this would be 1 plus 1 cubed. So the actual number doesn't matter. I just need to know, is this positive or negative? So on the bottom, that's going to be, well, I might as well work it out. That's an 8, 2 cubed. And then this would be negative 2 times positive 2, so negative 4. So that is negative. And when it's negative, that means that it's concave down, which means that there's a maximum where x equals 1. Then using the negative 1, so the second derivative, when you plug in a negative 1, so if you plug in a negative 1, that's going to make this a negative 2. When you square a negative 1, it's still positive 1, so this is going to be 1 minus 3. And when you square a negative 1, that's still going to be positive 1, so the bottom is still going to have 1 plus 1 is cubed. And then this would be negative 2 times negative 2 is positive 4 divided by 8, so that is positive. And then for positive, it means that it's concave up, which means there's a minimum. And then finally, it's time to graph it and see. So when you graph, make sure that you go back to the original function and graph the original. So an x divided by an x squared plus 1. And then zoom standard. Oh, it's a very short function. So let me change this. The x's are fine, but the y's, I'll try negative 1 to 1. Yeah, that's pretty good. So the function looks like this. So right here, there's a maximum. And right here, there's a minimum. And at 1, there's supposed to be a maximum. Yes. At negative 1, there's supposed to be a minimum. Yes. Excellent. So now I just need to label my answer. So I think I'll just put my final answer right here. So when you trace and you put in a positive 1, that means there's a maximum at 1, comma, a 0.5 or a half. And then minimum, when you substitute a negative 1, it's going to be negative 1 and then negative 1/2. And that is the second derivative test. All right, I'll talk to you again soon.